Hello and welcome to this BioProcess International Ask the Expert webcast. I'm your host, Leah Rosen, the online editor for BioProcess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Bris from Thermo Fisher Scientific.
Hello, I'm glad to be here. Thank you for the introduction. So I will speak today about how you can pack efficiently and easily rigid porous chromatography. You can see here a typical BioProcess purification protocol. Thermo Fisher portfolio of chromatography resins covers all chromatography steps for various biologics. First, we have the capture select line, offering unique and tunable affinity resin. And we have also the POROS line here, which are actually offering ion exchange and hydrophobic interaction resins. What are the unique features of porous bead? They are based on a backbone which is consisting on polystyrene divinyl benzene. It means that the beads are rigid, non-compressible, chemically and mechanically stable, and not fragile. It allows for very easy handling, as there is less risk of damaging the bead than with other materials. Second, on this zoom in of a bead with a scale of 2 microns, you can see that there is large through pores. The resulting large space allows for an improved mass transfer. So large molecules like viruses or antibodies can flow easily through the pores without being limited by diffusion. On top of that, all our bioprocess beads have a diameter of 15 microns. This results in a very high resolution, and it is still possible to get at high flow rate and scale owing to these large through pores. How does it translate on a chromatography run? On the left-hand side, you see 3 molecules being separated with a resolution to the baseline at different flow rates, ranging from 100 to 1000 centimeters per hour. So you can flow very fast. The flow rate doesn't impact the resolution, which is also a good example here with a red signal, which is for porous HS. It's one of our cation exchange, and an agarose bead on the green signal, which is having a resolution impacted when you get higher with the flow. Same thing for the dynamic binding capacity. When you go from 0 to 1000 centimeters per hour, the capacity of our resins, signal in colors, is not impacted. This is really due to the large support and the specific technology of porous resin. We can see here example of large-scale GMP production columns all around the world that are being packed with porous. As you can see, there is large diameters possible, like 1.4, 1.8 meters. We even have in Asia a column with 2-meter diameters, resulting in a column volume of almost 1,000 liters. They were all packed with a limit of 3 bar and operated at different flow rates depending on the pump's capabilities. Why porous is easy to pack and handle? There are specific features that I will describe. The polystyrene divinyl benzene backbone makes the beads being very rigid and non-compressible. It results in a minimal impact of the wall support when you increase the column diameter, so the beads support themselves. In a big and large bed, the bed would not collapse in the center. On top of that, the bead can withstand up to 100 bar pressure. So the pressure limit will not come from the beads, but from the skid or the hardware or the column. The beads also does not desiccate. So even if it runs dry without buffer, it doesn't damage the beads. And you can use then non-traditional methods to exchange a shipping solution by aspiration or sucking buffer with filter. We have optimized packing solution to use, but there is still a flexibility here. You can pack with water, salt, or sodium hydroxide. All these parameters means that POROS can be packed in all column types on the market, low pressure, high pressure, different materials. And you can also use very flexible packing approaches. You will reach robust results. Here, the typical packing method used with traditional flow pack, axial compression, pack in place or stall pack, and dynamic axial compression. The three last of this list doesn't need something specific to be done with POROS, so you just have to rely on the hardware recommendation. The first one, traditional flow pack, needs its parameter to be respected, and I will follow that in the next slide. If you flow pack a column, what is very important for POROS is that the packing flow rate is at least 50% higher than the operating flow rate, and the packing pressure, ideally 3 bar, at least 2.5. This is to ensure that the bed will not continue to be packed when you will be doing your process with your sample afterwards. Packing buffer are usually salt or water, depending on the resin you use and its ionic capacity. How you would do a packing, we would do in 2 steps. What is important once the slurry is into the column is not to let the resin sediment and to start directly at the ideal flow rate with no stepwise increase. The main difference between porous and soft resins are that you have to push the top adapter firmly directly onto the bed. It has to touch the surface and to be pushed onto the bed with the O-ring closed, of course. It is not damaging the resin or the beads. They will not be broken, and it is recommended and necessary to really push manually with strength or with pumps, as we can see on the picture. This ensures a nice packing. After that step, you would restart the flow, and if the bed would be getting more packed, you would stop the flow and repeat the pushing on the adapter. And that's it. The column would be packed. It's very straightforward. There is only 2 steps. You have no risk of damaging the beads, and when you use the right pressure and the right strength with the adapter, the resin is packed. For the other packing method, like axial compression with or without flow, stalling pack, dynamic axial compression, you would use a standard packing protocol relative to the hardware of the skid, nothing really specific for POROS in that case. But keep in mind, always pack at pressure and flow rates up to the limit of the column or hydraulics, ideally 3 bar. If a flow packing step is included in the method, keep the 50% difference between the 2 flow rates. And in general, the top adapter will stop when the resin bed is fully packed or the pump starts. Exception for the dynamic axial compression, where the pressure has to be determined depending on the diameter of the column. If that is your case, don't hesitate to take contact with us and we will support you with the right method. After you have packed the column, we recommend to condition the column by flowing alternatively in 2 directions with a packing buffer, 2 CV in upflow, 2 CV in downflow. You would see the bed is stable and adapt if necessary. The conditioning is important before the qualifying of the column, which is critical. You will need to determine the HTTP and the asymmetry using a non-binding analyte. We have very well optimized conditions for each of our resins. I cannot go into details now, but we can help you on spot and on demand. Usually you would use a qualifying flow rate, which is the same as the operating flow rate, qualifying buffers, which are standard, salt, water, and plug and pulse, which are also salt with typical percentage for the CV. There are many variables that can affect the column qualification results, and they are not specific to porous resin. The way you inject the plug or the pulse, the way you put it into the system, and is it diluted into the system before it comes onto the resin. The volume of the plug also plays a role. Qualification solution, buffers, and concentration have also an impact. Flow rate, it has to be not too fast, not too slow, it has an impact. Column hardware, either, for example, some hardware or column are designed so that the distribution cell on the top adapter will always give a bit of tailing in the asymmetry peak. This has to be taken into account. The system configuration, the scale, tubing, diameter, length, if everything is uniform or not, will have an impact. All these mean that you have to define a specific column qualification procedure for a specific system and stick to it. if you have a column that you have packed well with the right pressure and with the right flow rate, and there was no problem during the packing, but the concentration, the qualification results are a bit not ideal, please do not repack the column. There is probably more that you can do by just understanding the system and the method and understanding which parameters played a role into these qualification results. Very probably the column is well packed. There are examples of columns here where you can see in the world that they have been packed with different kind of methods, style pack, axial compression, different kind of column diameter in centimeter, because it was columns from all over the world and from different vendors. The packing buffer are not always the one we can recommend. Sometimes people just cannot use these and they have the standard one, but this is flexible. The flow rates and the pressure have been high enough according to our recommendation, and that's a type of result that you can obtain with this kind of condition that are still quite varied. HTTP and AS, HTTP is quite high, and asymmetry was always a 1:1, 1.2, 1.1. This is typical real-life example and not exception. I will come to my conclusion with the key takeaways. For the packing, POROS can be packed in all system column hardware. You don't have to adapt. All available packing methods can be used. And POROS resins are very stable, which is very nice to handle. You have no risk of damaging the beads if you take care and if you do normal protocol. It's not fragile. The qualification, we have standard buffers used to test, optimize, to show the best quality for each of our resins. Though test variables and parameters need to be defined and understood to really ensure optimal qualification. And this is specific to each system, skid, and pumps. Last but not least, the support. We can provide packing training for lab and pilot scale on site for the large team, and we also can accompany you and provide support during production packing or GMP scale packing on site. We correct your protocol, etc. All this support is free of charge. So don't hesitate to ask us. We are here to support you until the end. To finish, I will present here 2 packing videos that we have made for you. That's a lab scale and pilot scale column packing that you can find on YouTube very easily. They are very detailed and they are well explained, and you can find them by typing POROS column packing in YouTube. With that, I would like to close the call, and I'm happy to take your questions.
Okay, we have a few audience questions, so thank you, Anna. We will begin. One question is, I've had a lot of success packing POROS 50HS, but I have a very difficult time packing POROS XQ. Do you have any recommendations?
That's a good question, and I'm sure there is a solution. I think that would be maybe better that we talk offline, because I would have to ask your protocol and your condition and to see what is not the ideal condition for these. What do you think? What do you mean by having difficulties? Is it that you don't reach the right asymmetry, or the pressure is not good? Anyway, I'm sure there is a solution. I can help you offline. It should not be difficult. That is very easy resin to pack. There is surely something that we can fix.
Okay. Do these column packing recommendations apply at lab scale? We have been using POROS XS from 0.66 centimeters to 20 centimeters with mixed packing success.
Yeah, all the condition, great question. All the conditions are the same for all scales. So you would use the same flow difference, the same packing pressure, the same buffers.
Okay. What about fines? Is there any pre-treatment needed?
No, there is not. There is a specific step in the production of the resin itself, which is designed to remove fines. So it's a kind of washing that lasts for 3 weeks. So all the fines are already gone when you receive the resin at your site. There is sometimes submicron particle that results in a kind of a bit turbid first volume of washes, but they are not fines. It's just particle that goes away, and that has no impact on the packing. So don't bother about fines. They are gone already.
What do you suggest for packing POROS in a large-scale stainless steel column where you can't see if the bed further packs when flow is reapplied?
It's not an issue. Most of the large columns are packed actually in stainless steel. It's rare that you can see glass walls on column with large scale. It depends on the packing method you'll be using. If you use something with flow packing, the slurry amount has to be calculated very precisely. But for stall pack, you will calculate the slurry that has to get in, or for example, you would fix your adapter at the design bed height and pump the resin until you cannot pump anymore, or until the counter pressure would be above the pressure of the pumps. And normally, there is enough resin into the column and you reach your bed height.
Okay. How stable is porous resin in a 1 m NaOH solution? 1 molar. That's
1 molar. 1 molar sodium hydroxide. It's very stable. Most of them are very stable, except the POROS anion exchange resin, which are based on quaternary and tertiary amine. And as other resin, also non-porous amine, can be deaminated with sodium hydroxide. For a short time, for cleaning, sanitization, there is no issue. For long storage, we don't recommend such a high concentration for the anion exchange resin. For the others, it's not an issue.
Okay. And how is the compression factor determined originally, and what about the packing factor?
There is different packing factor depending on the beads, because most of our resin are on different beads with slightly different structures and pore size. So we have different packing factor. I didn't talk about this today because it was too long, but we can talk about offline. We have usually packing factor comprised between 1.06, 1.08, and 1.12, depending on the resin. That is the only packing factor or only factor you would take into account when calculating the slurry, because POROS is non-compressible, so there is no compression factor added to a normal packing factor. I hope it answers the question.
Okay. And what is the height limit for porous resins? Will the back pressure be higher than conventional resins?
No. There is, that's the contrary. There would be less pressure than conventional resin because of the space and the large support in the bead. So there is no or less diffusion area into the bead. So the pressure would not increase. Normally, at 1,000 centimeters per hour, when you flow at this flow rate, the pressure should be less than 3 bar. If you have more pressure, there is something wrong somewhere. The filters are clogged, or you have a very viscous solution like ethanol, or very turbid or dirty sample. It can be, but the pressure is usually less than other resins due to the structure of the bead.
And what's the recommended way to determine slurry concentration? Is it solution dependent?
No. So you would have the resin shipped in ethanol. On small volume, it's really easy to exchange the resin by just sucking the ethanol, and through Steripore or filter or any sucking device that you have, it doesn't play a role. You can just exchange with the packing buffer and suck again, and the resin would get dry, but it's not damageable for POROS, as I said. So you would just re-slurry in the right buffer, and if you can use this kind of method, in less than 15 minutes you have done your 3 washes, which are the number of washes recommended. For large scale, there is no such method. So you would wash using sedimentation, and in the very last wash, what is recommended is to take a small sample of 100 milliliter in a cylinder, a measured cylinder, and you will let sediment for a couple of hours and just read the concentration like that. You can also use centrifugation in small tubes to determine, but it is important that you determine with your centrifuges, and your speed and the number of G that you will use to determine what is equivalent to a gravity sedimentation. But there is nothing special to be aware of. Just for large scale, it can last a bit as POROS is very light, has a density of water, and it would last a bit to sediment. But the slurry determination itself is nothing special. You would just let it sediment or use centrifugation if you wish to do your own study on that.
Okay. Well, thank you, Anna, and I think that is all the time we have for questions. If we didn't get to your question, they will be given to Anna, and she can follow up with you directly.
Yeah, I can follow up on email, or we can have a call. I will be in touch with all of your questions.
Okay, and thank you to our audience for joining us. The recorded version of this webcast will be available for on-demand viewing on our website, and as a registered attendee, you'll receive a follow-up email providing you with a direct link. We look forward to having you join us at future BioProcess International Ask the Expert webcasts. Look for those announcements in your inbox. Goodbye.